Okay girls, this is the problem that we did Wednesday in class, and there's so many important parts to this problem that I just want to alert you to. And I'm going to kind of write them in the margins here, and then we'll start the problem. So one thing is this, that we know from our experience with the unit circle that that part of this equation always has to be between -1 and 1. The cosine never gets bigger than 1 and never gets smaller than -1. So that's a really, really helpful thing. We also know that the derivative of cos theta is equal to negative sine theta. So we might use that fact. And in this problem, we know this is the height and that's the time. And so if we're thinking about graphing eventually, we'll have a height axis and a time axis, and the time axis is going to go from 0 to 24. And let's talk about the height now. Since this can only be between -1 and 1, I know that and this is what it's talking about here, A, the maximum height, or the highest tide, is when cos t, or cos pi on 6t, equals 1. That's as high as this ever gets. So the height is going to be 5 plus 2 times 1, which is 7. And the lowest tide, even though it doesn't ask for that, I'm going to put it anyway. So this is the highest height. When this yellow thing is -1, then the lowest height, I'll put highest and lowest, is 5 minus 2, or 3. So I know that's high tide, and I know that that's low tide. The T is talking about hours after midnight. So A says, what is the height of the highest tide? So there it is, 7 meters. And I can just do it like that, that's fine. And when does it occur? Okay, well, it occurs when the height is 7. So I'm going to, or when cos pi on 6t is 1. And so on the unit circle, I say, okay, well, where is cos 1? And it happens right there. It happens at 0 and at 2 pi and at 4 pi and all those places that land right there. So I might go until I get my 24 hours, and I might say, oops, let me scooch up. I might say, so pi on 6t has to be equal to 0 or 2 pi or 4 pi, etc. So this gives me that t is 0. This, pi on 6t equals 2 pi. Well, to get rid of that, I have to divide by it. So 2 pi on 1, if you will, divided by pi on 6 is the same as 2 pi on 1 times 6 on pi, and that's 12. So at noon, after 12 hours after midnight, and you can see how I'm going to keep going with this. If I do the next one at 4 pi, I get pi on 6t equals 4 pi, so t equals 24. And those are my high points. Now, I don't have to do anything else if I use that method. If I don't use that method and I say, highest height, that's maximum, okay, so the harder kind of method that we did in class yesterday would be to say, okay, I'm going to find dh dt and set it equal to 0. So if I take dh dt of, I better write my function down again. I'm sorry I'm all over the place here, but I'm fitting it in a small spot. If I'm taking the derivative of h with respect to t, the derivative of 5 is just 0, and the derivative of this is -2 sine pi on 6t times by pi on 6. So it's negative pi on 3 sine pi on 6t. Make sure you can figure that out. And when I set that equal to 0, I'm going to get both the maximum times and the minimum times. And we did that yesterday. So we had many times. And we had to do a calculator for a minute. We had to do a first derivative test to figure out all those times. So I think this method is so much easier. Yesterday we typed in 5 cos pi on 6 and we graphed it, and it was really easy to see what the graph looks like, and it was easy to see that at 0 and 12 and do this problem here, it's also going to give you the minimum values. So this turns out to be a bit harder, and we did that in class yesterday. Okay, let's look at B. B says, what is the difference in height between high and low tides? Well, that's very easy because I already figured them out on top. High tide was 7, low tide was 3, so 4 meters is the difference. And part C says sketch the graph, and I can do that straight from the calculator. So 24, 12, 0, I might put 6 and 18 in, and I'm going to put in 3 and 7, and right in between there the average of those two numbers is 5, so that's where my equilibrium is. Okay, and I could tell that from my function here. That's the D usually, and that's where the equilibrium is. And I know that there's a high point and a low point and a high point and a low point and a high point, and that's good enough. And I just want to try to get the curve looking kind of like a cosine or sinusoidal curve, and I can graph it right off the calculator. That's fine. Okay, and then part D says John North knows that his trawler needs a depth of 6 meters to enter the harbor, and between what hours can he do this? And so I'm going to go 6 for my depth, and I need to find these places. I need to find these times where I'm at 6 meters. Now yesterday we did that by hand, and it took a really long time, and if we're using our calculators, another way we can do that is to go to y equals and put y equals 6 in and graph. And then I can find each of these intersections, and when I find those intersections, I'm going to scooch way over here. When I start to find those intersections, it wants me to be to the left, so I'll go enter, enter, enter. And I can see it hits at x equals 2 when y is 6. So time for D, time 2 a.m. is where I get my first time. And if you do that for each intersection, you'll be able to tell the times when it's deep enough for him to get in the harbor. Okay, work on this problem again by yourself, please.